Shake divides all their color nodes into basically two groups, what they call atomic nodes and consolidated color correctors. In this movie, we're going to look at the atomic nodes. In the next movie, we'll look at the consolidated color correctors. The idea of an atomic node is it applies a single simple image processing operation to the image. In this movie, we're only going to look at a few examples. So to do that, we'll load ShakeScript 05 and go to our pop-ups, exercise files, chapter 15, ShakeScript 05. The ramp is loaded into the viewer, but we need to turn on the plot scanline feature. Down here on the viewer tab, this little guy here, pop up, and select this little squiggly line guy. The plot scanline is a diagnostic tool that comes with Shake. This line across here is the scan line that it's analyzing, and it graphs or plots the RGB values across that line here in the graph. So at the left edge of the scan line, it's seeing 0 black, which is down here. Here it's a dark gray, which we see there, and over here it's a bright, which we see up there. We're going to use this as an aid to see how all these image processing operations work. I'll double-click on the gamma node, and look what happens to our plot scan line as I adjust the gamma down and then up. You can also adjust the gamma individually in each channel, so we can turn the red down and the blue up. The important thing about the gamma operation is it does not disturb the white point at 1.0 or the black point at 0. Most of the other operations do. Let's double-click on the brightness node. And now I'm going to control, click, and drag down, which lowers the brightness. The brightness operation is scaling all three channels equally by the value you set. If we go the other way, scaling the brightness up, I'm now clipping pixels. Any pixels that were up here, like code value 0.9, is clipped, gone, out of the frame. The multiply node behaves just like the brightness node, but it allows you to apply a brightness, if you will, to each channel individually. So I can bring the red channel down and the green channel up and leave the blue alone. Of course, the green channel is now clipping at this point. The add node simply adds code values to every pixel in the screen. And because we see three windows here, we know that we can adjust the red, green, and blue individually. So I'm going to raise the red up, which took the other two channels with it. Then I can bring down the green and then bring down the blue. This red channel is being clipped right here, and this blue channel is being clipped right here. Now let's go down to this ramp and look at three more very important nodes. We'll double-click on the compress node. And the compress node squeezes the black and whites together to lower the contrast. The number in this window tells you the RGB value that the blacks are going to be pushed up to. And the number in this window tells you what code value the whites are going to be pushed down to. So as you can see, the image has lost contrast. The expand node works in the opposite direction. This is going to stretch or expand the image, increasing the contrast. So the numbers that you put in this window are going to be pulled down to 0 black. And the numbers in this window are going to be pushed up to 1.0. As you can see, though, we've introduced clipping in the whites and the blacks. The lookup node is an extremely important node. In fact, we're going to open that with a Control-T, a tweaker, so we can get a better look at it. These are the color curves and are very powerful color correcting tools. They can be a little difficult to work with, however. So we can turn on one color channel at a time. I've got the red turned on. And I could, for example, scale it down. I could turn on the green channel, I can scale it up, and I can pull its black levels down. And then I can turn on the blue channel, and on any one of these channels you can insert a control point and actually bend the curve. The important thing about the blue channel is I did not move the white or the black point, so I did not introduce any clipping. Whereas the green channel, I've introduced clipping in the whites and clipping in the blacks. We can also combine nodes. For example, we'll take this gamma node here, we'll copy, Control-C, and paste, Control-V, the brightness node, and now these two operations are together. We can even copy, Control-C, and paste, Control-V, the compressed node, and produce this. Now if I switch to the enhanced view with Control-E, we can see the concatenation between those three nodes. So you can combine the atomic nodes in any order you wish to create a color correction operation. Now here's a couple of nodes I wanted to go over with you because they're very similar and kind of confusing in what they do. This ramp has color in it, and I've attached a contrast loom and a contrast RGB node, and they appear to do very similar things. So let's take a look at the distinctions. I'm going to double click on contrast loom 2 and enter a value of 1.5. So it's increased the contrast of the picture compared to the original ramp. See, all the lines got steeper. The important thing though, contrast loom is really increasing the contrast of the luminance of the image. As a result, as the bright parts of the picture get brighter, they converge towards white, as the black parts of the picture converge towards black. Compare that to the contrast RGB. Double click on that. We'll set it for the same value, 1.5. It increased the contrast, but it's increasing the contrast of each color channel individually without converting the image to a luminance version. As a result, compared to the original, the contrast RGB increases in saturation. So there you go. Contrast luminance tends to desaturate the image as it increases the contrast. Contrast RGB tends to increase the saturation. Not all the nodes on the Color tab are color correction nodes. Some of them are what Shake calls utility correctors. What they do is they prep images for other image operations, and I'd like to show you just two important examples. To help with the demo, we have Marcy today, and as you can see, she's got the plot scan line all over her face. So let's come down to the viewer shelf and turn that off. There, she looks much nicer now. I've added a set alpha node so that I have an RGBA image. So we now have a 4-channel image in the viewer. The first important utility node that you'll be using a lot is the monochrome node. This turns any RGB image into a single-channel grayscale image. You see up here, Shake says it's a black and white image with an alpha channel. So this is how you convert an RGB image into a grayscale image, or a monochrome image. The reorder node does something completely different. The reorder node allows you to swap the color channels in any way you'd like. For example, we'll come down here to the channels. What you see displayed is put the red in the red, the green in the green, the blue in the blue, and the alpha in the alpha. So if I want to swap that around, I would enter, for example, BGRA. That means put the blue in the red channel, put the green in the green, and put the red in the blue channel. As a result, Marcy now looks like this. Very attractive. But the real important function I wanted to show you is this. I'm going to enter RRR0. This is counterintuitive. What I'm saying to Shake is, take the red channel from the RGB image and put it into all 3 channels and no alpha. That's what this 0 means. You can also use an N. Either one will work. Shake says, oh, you're putting 1 channel into all 3 channels. You must want a 1-channel image. Looky here, black and white. So what I've done is, I have pulled the red channel out of an RGB image and made it a single-channel image that contains only the red information. In this movie, we took a close-up look at a selection of the most often used and important atomic color correction nodes. We also saw a couple of utility color nodes, the monochrome and reorder, which allow you to make grayscale images or to isolate 1 single channel out of an RGB image and make it a 1-channel image by itself.